Welcome viewers and subscribers. Welcome again to another video. This is JK Engineering and Architecture. We are coming to you with engineering, architecture as well as construction related topics. Now in today's video, as promised, I said I was going to introduce to you structural engineering. Now structural engineering, as it might come across to a lot of people, it might not ring a bell to most of you because most of you are familiar with what the architect does. But in the built environment, there are several professionals that I want to bring to your attention. And I'm going to shed some more light as it relates to the engineering aspect of the built environment. Now, before I actually get into that presentation of structural engineering, I just want to give you a background knowledge of where structural engineering is coming from, or even architecture. Because for most of us, when we go to school or universities, they do not tell you the origins of where these things are coming from. And based on my philosophy, I like to give people a background history of where these things are coming from. Now, as it relates to architecture and engineering, that I can relate to readily, architecture and engineering is coming from about 10 to 15,000 BCE, before the Common Era, and this is originated, as far as I know and as far as I study, in the region of North Africa, to be exact, ancient Kemet, or what is known today as present-day Egypt. In some religious spheres, ancient Kemet is referred to as Mizraim. But in terms of documented history, the correct name for that region, or the correct name for Egypt, is ancient Kemet. Egypt is a name that was coined by the Greeks, and we can get into history at some other point in time. But we date back engineering and architecture to the building of the pyramids of Egypt, and especially as it relates to the first pyramid that was built under King Zoser, which has his vizier as Imhotep. Now, this is history that you can go back and research to relate to what I am saying. Right? So, under King Zoser, with his vizier Imhotep, the first architecture and engineering structure was built, and that was known as the Step Pyramid of Saqqara. So this is history that, if you want, and in the comments you can ask me to shed some light on that as well, because also I'm a big fan of history as it relates to African history. Now, having said that, to bring you back to the here and now, now we know in typical terms that when the architects design the structure, the architect then employ the services of a structural engineer to design the structure to withstand the impending loads, such as the wind load, earthquake loads, and gravity loads. So let me shed some more light as it relates to the different professions that are in the built environment. Now, in the built environment, we have one, the architects, we have engineers. An engineer can either be civil or structural. I'm going to shed some more light on that. We have surveyors, which is land surveyors. We have quantity surveyor, as most of you who have done construction know what a quantity surveyor does. We have planners, and we have construction managers. Now, these are the six professionals that I can readily detect. If there's more, you can let me know, but I presume there can be more. There is more, right? But these are the ones that I come up with readily. Now, under civil engineering, we have structural engineers, we have transportation engineers, we have environmental engineers, we have construction engineers, and we have hydraulic engineers. Hydraulic engineers are engineers that design water structures such as dams, reservoirs, and all that, but it still has to go back to the structural engineer. And we have geotechnical engineer. Now, the role of the structural engineering, of a structural engineer, in my opinion, structural engineering governs all aspects of engineers and all aspects of the built environment. So whether you're building a building, roads, bridge, dams, reservoir, railway, underwater structures, aeroplanes, all of that has to do with the structural engineer, because the structural engineering is responsible for all those structures that I have mentioned to you just now to maintain its structural integrity. In other words, those structures are safe for people to utilize on a daily basis, and it is also safe when other elements is impacted upon it. When it comes to structural engineering, there are four main topics under structural engineering, and they are as follows. There are mechanics of solids or mechanics of material, structural analysis, reinforced concrete design, structural steel design, and wood design. Now, for the purpose of my videos, I'm going to be going mostly with some aspect of structural analysis, but I'm going to do more reinforced concrete design, since our building is mainly constructed of reinforced concrete structures or reinforced concrete members. In addition to that, to understand what I'm going to be demonstrating to you, there are several principles of structural engineering that you must come to terms with. And you are going to hear me refer to these terms from time to time. The loads as it relates to point loads, which is PL, uniformly distributed loads, which is UDL, moments, which is equal to force times distance, and reaction and equilibrium. Now, when it comes to reaction and equilibrium, especially when you're dealing with concrete beam design, now for that beam to be stable, it means that the forces that are acting down on that beam must be equal to the forces that is acting upwards on that beam, for that beam to maintain stability. In the first or second laws of motion, it states that for every action, there's an equal and opposite reaction. So for any structural system or for any system to remain in equilibrium, the forces that are going in one direction on that structure must be equal to the forces that is going the other direction on that structure. And also to establish equilibrium, the beam is going to impacted by what is called clockwise moment and anti-clockwise moment. So that simply means that the moments that are going clockwise must be equal to the moments that are going anti-clockwise. So I'm going to get into those calculations in my next video. This video is only to introduce you to the topic of structural engineering. So in the next video, you're going to see me work out reaction, equilibrium. You might see me touch a little bit on structural analysis, but this is going to be a series of videos just to give you somewhat of a comprehensive knowledge of what goes on when it comes to beam, column, and slab design. So I'm going to stop this video here and continue with my next video next week. So ensure to tune in to this topic. This topic is a very important topic as it relates to the built environment, and as I've said earlier, that I know that most of you are pretty much familiar with what the architect does. So now it's time for you now to see what goes on the engineering side. So take care of yourself, and if you're new to this channel, ensure to hit the subscription button, leave a comment, and hit the thumbs up button. Thank you and enough respect.